Hi, everybody, and welcome to this Refinitiv Developer Community webinar. I'm Jason Ramchandani. I'm the Developer Community Manager and Advocate here at Refinitiv. This event is part of our Developer Events Program, and for more events, you can just go to developers.refinitiv.com and see the upcoming events there and much, much more. Full of developer resources there. This is a recorded event, and you'll be receiving all the slides and all of the code that you see in today's webinar. You'll be receiving that in a follow-up email. Okay, so I'm just going to go and talk about some kind of housekeeping points now. So essentially, you can use the widgets at the bottom of your screen to discover the platform features. You can adjust widget sizes, such as the slides widget and also the live screen sharing widget, and you can drag those around and resize them from the corners of the boxes. We'll also be conducting some votes today, so on the slide portion of the window, you'll be able to just click, have this interactive polling functionality in real time. So just click on an answer, and then we'll collate, and we'll all see the results in real time. And then you can submit any technical queries by clicking on the question mark icon. And then obviously throughout the webinar, you can submit questions via the Q&A chat box. We'll try to answer some of those as we kind of progress through various stages of the presentation, and at the end we'll try and cover any that we haven't been able to do in the interest of time, but we don't want to disrupt the presentation too much. And at the end, there's a pop-out survey at the end, and if you could just fill that out, because that helps us to provide to incorporate your feedback on what you like, what you didn't like, and so on and so forth. So if the slides are stuck at any point, just refresh your browser, and in any other case, just hit the question mark, and then we can deal with your queries there in real time. Okay. So today, we're really delighted to have Felix Zumstein with us. He is, before starting xlwings, he was a director at UBS Global Asset Management in Zurich, and he left there in 2014 to build a solution that could bridge the gap between legacy Excel VBA technology and the more fast-moving modern Python world with its ever-evolving kind of ecosystem, and that product was called xlwings. So Felix holds a master's degree in finance and economics from the University of St. Gallen. He's also a CFA charter holder, and he's based in Zurich, Switzerland. One of the interesting things about this presentation, I mean, I've known Felix for a couple of years now, is basically, I used to come from a spreadsheet programming background myself. And, basically look at spreadsheets as a highly flexible, interactive app, really. And for years, this flexibility was very highly prized. It was a massive productivity tool, has connections in and out of lots of things. But obviously, the stuff that made it really successful also presents, when it scales out, it presents some problems and concerns for as part of, if spreadsheets are used part of mission critical processes. In particular, we'll be hearing more about that from Eve. So, treating spreadsheet as code has become sort of more popular now. So, formulas in cells, data and variables in cells, and off-book sheet references. This is all like non-procedural programming. And then you've got on top of that, each of the stuff can be modified by, add-ins, by APIs, VBA itself, and .NET, and lots of other things as well. So, you're going to hear about Python today as well. So if we look at the modern sort of spreadsheet, has up to 1 million rows and 16,000 columns per tab. That's 16 billion potential lines of code per tab. Now, you may disagree with these. I'm just go with me for a bit. And the highly interactive nature of these sheets, as we've said, many people can edit one sheet, and so we start to build, more and more, so from that 16 billion for per tab, how many sheets in a workbook, and then how many people have access to that workbook, and so we can start getting, to some real complexity, order of magnitude complexity, which is actually quite large and potentially quite worrying. We'll hear more about that from Felix in a second. So I think it is a real problem, and what do we do about it? And without further delay, I'll hand over to Felix. Please help us.
All right. Thanks so much, Jason, for the introduction. And hello, everybody from my side. Thanks for having me and giving me this opportunity to talk about, let me find the title slide, to talk about spreadsheets and in connection with Python and financial data. So obviously today I'm going to be focusing a lot on the interaction with Eikon and Excel and Python, but we will hear a lot about what Jason just mentioned in terms of stability and risk of spreadsheets. So I have planned this webinar to have 3 sections. First of all, I'd like to say a few more words about what we do, and then I'll kind of search a little bit for some justification why we are still dealing with spreadsheets when everybody else is has moved on to AI or the blockchain. And then still the focus of today's demo or today's webinar will be on the live demo, where I will be showing you about 5 different cases how you can use Excel together with Python and make more out of Eikon and make more out of probably many other tools that you're working with on a daily basis. So in terms of introduction, we see our mission here at xlwings as basically providing innovation and innovative solutions to de-risk Excel spreadsheets. So we want to give you tools that allow you to stick with Excel, but to make your life a bit more enjoyable. And by doing this, mainly to take away the typical risks that you face by using Excel spreadsheets. And the 2 tools that we mainly built to tackle these issues are xlwings. So we're going to be hearing a lot of xlwings today, so don't have to spend too much time on this. For now, it's been around for about 6 years. We've been around for 6 years with basically the open source version. And at the end of the last year, we have introduced a pro version in the hope to continuously finance the further development and maintenance of the library as such. And then we do have another tool which is called Excel Trail. And Excel Trail is basically taking care of the version control for Excel workbooks. So it's one of the issues that we see often happening because Excel workbooks are just treated as a file and being sent around, and everybody does funny things. We tackled this basically in the same in the same spirit as GitHub tackles it for standard code. So the idea here is that you can look into your spreadsheets, you can see what's going on, you get your audit trail, you see who changed what, when, and why. And we're going to have a quick look into how this actually looks in practice at the very end of the demo section. And with this, I would like to say a few words here as promised on why or how we are still dealing with spreadsheets in 2020. And it's probably true when I say that when you hear about Excel spreadsheets nowadays, it's not because Excel has added some AI capabilities, which indeed they have, but it's mostly because there was yet another spreadsheet error happening somewhere. So just like I've picked 2 of them, one here, as you can see, is the Marks and Spencer case from a couple of years ago. And they basically reported a growth in revenues, quarterly numbers, whereas indeed it was a drop in sales figures. And that was caused apparently by a double counting issue in a spreadsheet. So it's kind of an example where sometimes you wouldn't assume companies do still rely on Excel, but apparently it still happens all the time. And the other case, I guess, doesn't really require a lot of introduction. It's probably one of the most one of the most famous cases, the London whale. And in the paper that was actually looking into exactly what happened, they were basically pointing out two spreadsheet errors. One of them was that there was involved some manual copy pasting with a couple of spreadsheets involved, like a real classic in a sense in spreadsheet world. And the other one was that there was a logical error. So they were using a sum, I believe, instead of an average, or the other way around, and therefore had a figure, a risk figure, which was wrong in that regard. And so these things happen because Excel spreadsheets are basically used in a bit of a cowboy style, right? So this tweet here is kind of really nicely summarizing how people deal with their files on disk. So they just add _v1, _v2, _edit John, and in the end it gets sent back and forth. You kind of lose the overview of what's happening. So definitely one of the issues that I mentioned initially, we tried to get a grip on with our tool Excel Trail. Now the other one is probably something like this, and I'm pretty sure that all of you have written similar formulas, so you can see a lot of things happening here. So first of all, it's very difficult to understand what's going on. Even if you have the full spreadsheet at hand, you kind of have to find out, okay, so where exactly does it index matching things into? And it's unstructured, so it's like a nested. I mean, here you have got like a nested, a nested formula here, really, with a couple of offsets and index matches. So it's really, really difficult to see what's going on. And one of the things we can do about that issue is basically using Python to strip out all the business logic from single cells and basically have the logic in Python where it's easy to do version control, it's easy to collaborate with many people on it, and it's easy to kind of work with variable names that mean something like more intuitive than like, odds B3. And in essence, what we have come up with on basically on working with many clients and taking care of their spreadsheet problems is that it really helps to look at Excel as a fully fledged programming language. Admittedly, it's a bit of a funny one. It's a programming language that is like in constant debug mode. So you can see all the values on your Excel spreadsheet, on your cells, but you can't see without going on each individual cell what the formula is behind. But nevertheless, you write fully fledged if statements in your cells, and it's really a way of programming. And a lot of managers, a lot of companies have the idea that the only solution to kind of bring these spreadsheet issues to an end is by just fully migrating away from them. But we have kind of started to understand or started to see that this is, well, maybe not a bad idea, but in practice, it just simply isn't always possible to do that. So if you are maybe a small team with many technical users, so let's say like a smaller hedge fund, then indeed moving away from Excel may be completely possible and a good thing to do. And we've actually done that ourselves. We've helped the hedge fund to move away from like a 60 megabyte spreadsheet onto Jupyter notebooks and a web-based trading system. But there's other teams that you can try how hard you want, no matter what tools you build. Like the download to Excel button is still going to be the most prominent functionality of that tool. And so we find that it's just a fact that Excel is not going to go anywhere for the majority of businesses or for the majority of basically teams in a business. And so it's about time to kind of look at Excel as something to stay and just trying to provide the the tools that are missing to make the work with Excel a bit safer. And these are basically tools that we see in programming languages, and we try to kind of bring them and adopt them to Excel and make your life a little bit easier. And so obviously one of the best ways to kind of get away or get rid of many issues is to get rid of the manual interaction with Excel. The copy pasting that happens on a daily basis, I'm sure, in a lot of teams, except probably yours, I'm sure. This we can get away with switching or bringing Python into the picture here. And so that kind of leads the way here for the interactive demo part. And before we start that, I obviously want to go through basically the different samples that I'm going to show you. And as I initially promised you, there's about 5 different samples, and each of these samples is trying to kind of shed a different light on how you can use xlwings. So it's a different use case, and each of these are leveraging the connection with Eikon at the same time, except for the last demo here. So we are going to kick this demo off by starting and looking at the Jupyter Notebook sample. And before I do that, I would like you to here actively take part in this poll and let us know if you are using Jupyter Notebooks on a regular basis. While you do that, I am going to share my screen now to be able to show you what's going on. And I believe for you to get the best out of it, you should make sure that you maximize the window where you see my screen, so you're able to actually read the code, at least from a high level, what's going on. Usually the question comes like if you can get access to the sample code, you definitely will. There's a GitHub repository that we will share the link with you. So you will definitely be able to get and download the sample code for all of this that I'm showing today. All right, so let's get started. So many of you probably use Jupyter Notebooks to do some interactive research. What I'm doing here is obviously the notorious imports first, and then I make the connection here to my Eikon terminal. And then I just use the Eikon API to query a time series. So I'm using the Eikon package here, and what I get back is a data frame. And so xlwings can come in a few different ways here, but one of the most simple way is you can use xlwings just as a tabular data viewer. So, if anything that probably everybody agrees on is that if you don't like Excel, it's still a very good tabular data viewer. Let me make that a bit bigger. And as you can see here, basically, well, on the notebook, it's sometimes a bit awkward. I mean, if you really want to scroll through the data and see like what's going on, sometimes good old Excel is just like the best UI. You can set your auto filters here. You can do some like color formatting, some conditional formatting if you want. It's just very, very convenient to do that. And the view function here is basically just accepting pretty much any Python object you may have. Usually, I guess it's a data frame, but it can also be like a NumPy array or some other sort of thing. So that's like the quick and dirty way of doing things. But xlwings basically gives you a full API to remote control Excel. And at this point, like if maybe you have a doubt about how xlwings compares to other Python packages, then xlwings really controls the Excel application, whereas, for example, OpenPyXL, they would really write to the file and read from the file without using or without relying on the Excel application as such. So these two different use cases. Some use cases obviously overlap, but most of the times you use both packages for different things. So now this here is the API, and by the way, xlwings, everything will work on Mac OS as well as Windows here. So I'm demoing it here on Windows, but everything except for user-defined functions that we will get to after this will work cross-platform, which is pretty unique. So as you saw, firing up a new workbook here is basically as simple as here calling a book class here. And then you can use a Pythonic way to really talk to the Excel object model. So you have the sheets collection here. You can index into it and really talk to a specific cell in here and just assign here basically the data frame that we just pulled before from Eikon, and you can just throw this over to a top left corner in Excel. And then on the way back, if you have basically a source, if somebody delivers you a source in Excel, you can also just say, specify that you would like to get it back as a pandas data frame in the options method here. And you are basically back to where we started here by the original data frame that we got out from the Eikon terminal. So this is really, in a nutshell, how xlwings works. It gives you an easy access to remote control your Excel application. And at this point, I would like to go back to the poll and see how the poll has come out. So we have 35% who say they use the notebooks on a regular basis, and then 64% no. So maybe I can wholeheartedly recommend you to look into Jupyter Notebooks. They are awesome. Like especially if you start off with Python, they are awesome to play around and see how everything works. And at this point, well, kind of a follow-up question. Did you know that there are easy like Python packages in Excel? Well, Python packages that deal with Excel and allow you to automate Excel, or maybe also write to Excel. You can understand this a little bit more generically. So if you can take care of that question now. And then I'm going to prepare basically my next demo, which is about user-defined functions. And as I said before, so user-defined functions are basically the only functionality in xlwings that is only available on Windows. So this here is only on Windows. Everything else is cross-platform. All right, so before I get started, I will basically show you the poll result, which said that basically, again, basically same ratio as before. 34% knew that Excel and Python are kind of made for each other, and the other one here, which is awesome. All right, so for the next demo,
Felix,
here, yes,
Felix, it's we just had a question, and while we're here, let's just deal with this quickly. So Darcy's asking, can you manipulate all Excel objects via xlwings? And I think you can do most, but more importantly, I think are you not allowing people to bring in different types of objects now with your Excel Pro upgrade?
Right. So you can. Okay. So in theory, yes, you can manipulate the whole Excel API. In practice, we have basically natively implemented like the most important ones natively in xlwings. So it looks like a Pythonic API, and it works cross-platform. That's basically the definition of natively available. If we do not have a function natively available, what you can do is basically you drop below to the lower level to the lower level packages that we're using. And on Windows, that would be PyWin32, and then on Mac, that would be AppScript package. And these generically cover everything. So you can write code that covers everything. It's just you have to do a little bit more work. And for the time being, it's going to be platform dependent. But to make the long answer short, yes, you can, but you may have to drop down to the underlying lower level packages. It's covered in the online documentation.
Thank you.
Okay. So this is the correlation sample here, and I'm going to show you how it works first and explain you a bit behind the scene how everything looks after that. So the way it works is you can basically program your user-defined functions in Python, and then just make them available like every normal user-defined function in Excel. And what this function does is basically it goes to Eikon, it fetches down time series, and it calculates the correlation out of these time series, and then brings it back to Excel. And you can go a step further and say, okay, now instead of doing just the correlation map, the correlation matrix, I actually would like to have a correlation heat map. And Excel makes it a little bit difficult to produce a proper heat map. So what I'm doing here is I'm using a matplotlib chart. In more details is actually a Seaborn chart, which makes it incredibly easy to come up with a heat map. And then so the best part about that is it's dynamic. So I can just go here and include a few currencies here, and automatically I will get both the correlation matrix updated, but also the matplotlib or Seaborn chart here. And I can see in the heat map how my currencies are correlated to my stocks, my US stocks over here. And so how does this work behind the scenes? We do have a little bit of Python code in here. So if we look at this, let me get to the correlation sample here. Then it's basically pretty much what we've seen before. So it only consists of an Eikon query, get time series, I get back a data frame. I can do a few manipulation on a data frame, and I guess that's like where it maybe has an edge on existing like Eikon Excel integration. It's easier to write your customized your customized kind of functionality into a user-defined function. So I can simply use the pandas methods of dropping NAs and then doing the return calculation, and then really just using the correlation method on the data frame and basically returning that. And this is about it. So I need to decorate the function with an xlwings function decorator. And then in Excel, I will actually have to import those functions first before I can use them. I only have to do that, one time. And then that's basically it. And then the sample, or the second part that I was using, is the Seaborn heat map. And again, it's really simple. So again, you just mark the function with an xlwings function decorator, and you decorate the function and say, okay, well, the correlation, basically the input that we are reading in, you want it to be arriving as a pandas data frame. And so it's kind of, there's almost no more work for you left. So you just, use the heat map from Seaborn, format it the way you want, and basically create a picture, and then use the xlwings API here to give back that picture object. And that's pretty much it. So it's really just about leveraging the functionality you have in Python, so that you don't have to reinvent the wheel as usually you would have to do it if you use VBA for like everything you do in your quantitative world. And at this time, I guess it makes sense to check out what the poll says. So we do have similar results here. Again, the majority here, 2/3, they do not usually use user-defined functions, which I guess is generally speaking not such a bad idea, because the less user-defined functions you use, the less business logic you have in your spreadsheets, and the less business logic you have, the less issues basically you will have, or like the easier to control an Excel workbook it is. All right, so for the next demo, which is about reporting, I would love to hear your feedback about what are you using for reporting purposes. Are you indeed using Excel already, or are you falling back to more like BI tools or something like Plotly Dash, which produces interactive HTML-based reports? So switching over to my reporting sample, it's actually funny to see that from what I hear, a lot of people do use xlwings really for reporting purposes. And it's funny because when I initially created xlwings, it was more for the use case that we will see after this one, which is kind of, getting access to Python's scientific libraries. But it turns out that a lot of people use xlwings for reporting just because it makes it so easy to fill in existing template. Yet we have been told by existing users that this wasn't good enough for them. So And this is what I'm going to demo you here. So this is basically the only demo that requires the xlwings Pro functionality. And as I said, I mean, there's obviously plenty of people who use the community edition to automate their reporting. It's just that the Pro version gives you a few features that are really, really handy to use. So the idea here is that you produce your reports based on templates, and that means that the person who writes the Python code to connect to your SQL databases, to connect to your Salesforce API, to consolidate the tons of CSV files that come in every morning, that person doesn't necessarily have to be responsible for designing the report. And so the xlwings reports package here, as part of xlwings Pro, basically really offers you to completely separate the data part from the design part. So you can basically just tell a business user who does not have any clue about Python how your data is being called. And they can then design basically the template with these placeholders here. So you can see it's basically placeholders in double curly braces. And I've just kicked off basically the reporting process because it'll take a few seconds to fetch all the data from Eikon, prepare it, and then paste it into all of these placeholders, what just happened now. And so if for a moment I put them side by side, you will see a few things happening. So let's concentrate here on the right-hand part for just now. So you can see that I have had really a, let's make it a bit bigger here. So I've had really just a table here, which constitutes here of a header and a single data row. And we have applied here some conditional formatting. So the business user, again, can just go in here, say, okay, well, this is exactly the place where I want the constituents to be placed, and I want I want to use this this conditional formatting, the bars, so that everybody can see that year to date, unsurprisingly, Microsoft is doing the best on the Dow Jones here, whereas if you scroll down, again, not very surprisingly, you have Boeing here at the bottom with a -60% performance from year to date, from the start of the year to date. And so xlwings reports basically not only replaces the placeholders with the tables, but it also does take care of dynamically shifting and formatting your table to as many rows it has. And then basically below that, as you can see, replaces those metrics here, the performance start and end date, this is weekly performance, so this should be probably end of last week, and then pastes, rearranges like everything below the table dynamically. And so this is really nice because now the business user can go in here and say, okay, well, I would like to have the reference date here as part of my here as part of like my source below below each chart, and they just have to do this. They run it again, and again they will have the reference date below accordingly replaced by whatever you deliver from the Python source code. So you don't have to go back to Python. You can put in an empty line here. The business analyst thinks, okay, there's not enough white room, and you just change that, and there's a zero code change required for you when you change your template. And that's pretty awesome because you can really organize yourself better and split the work in two. And again, at this point, obviously, I would like to have a quick look at what's going on behind the scenes. And actually, there is another feature I was demoing without telling you up front. So xlwings Pro allows you to embed the Python code in Excel itself. So this is obviously not a feature you would use to develop your tool, but it's a very, very handy feature you can use for deploying your tool. So the community edition kind of requires you to always send around the spreadsheet and then kind of also deploy the Python code alongside with it. So it can be next to the Excel workbook, which probably isn't such a good idea if the person has not really an idea about Python who is using it. But it can be, I mean, you can also deploy it to like maybe a shared drive. There's tons of different options you have there. But definitely the easiest solution here is to embed the code here in a spreadsheet. So if you update your tool, then you just have to send around or just update a workbook on the shared drive, and you don't have to care about deploying the Python code on top of that. So that kind of gives users, gives them really the look and feel 100% of how Excel or like a macro-enabled workbook works. So that's just to tell you that. But let's still look at the, I think I have it open here too, yeah. So let's look at it here just to get a bit of syntax highlighting that makes it a bit easier for you to digest. Again, I mean, there's some, optional configuration part I have here. I didn't even demo that, so let's ignore that for now. But again, it really comes down to having a call to get to your data. Here, again, familiar get time series call from Eikon. Then you get, again, like close price and so on that I was using here on basically here on the left-hand side. These data here were done by the get data call, and then here was the constituents call. So it's just really a series of API calls to Eikon, and then in the end, it really boils down to having a couple of source data. These can be data frames mostly, but they can also be like lists, they can be like strings. And then in the end, what you need to do is really just you call the create report function, you give it a path to the template, you give the path to the report, and then basically you provide the data here that we prepared here in the dictionary. And if you've ever worked with a web framework like Django or Flask and used some templates there, then that's absolutely the same way that it works. We do use indeed the Ginger templating mechanism from Flask behind the scenes, so there really isn't too much of a surprise here. But as I said, it's a really, really flexible setup to get some dynamic reports going and have business users basically own their reporting design again. All right, so that was the reporting sample, and that brings me to the poll results here. And as you can see that there's a staggering result of 84% of people using Excel indeed for reporting. So that really, really is in line with our own surveys that we have done about 1 or 2 years ago now, that basically then led us to build this dedicated reporting tool on top of the community edition. And definitely Power BI and the likes, they are also quite popular. So, right. So this one here is basically the next poll question is basically about computational performance. I mentioned it before. It kind of was one of the starting point why I started to build xlwings, so that you could get access from Excel in an easy way to functionality in Python, like computationally intensive functionality. So feel free to respond to that poll during my next demo here.
And can you take a couple of questions?
Sure. Oh, absolutely, sure.
So, yeah, just we're having quite a lot coming in, so I thought we better handle some of that.
Sure.
There's a couple of questions here. So, is it possible to use xlwings Community Edition in companies, or do I have to buy a pro license? That's the first one. And there was a number of other people asking the things that you're showing, are they in the pro version or are they in the free version?
Okay. Yeah, sorry about that for not being more clear about that. So the reporting sample was the only sample that is covered by the pro version. Everything else that I showed today is all in the Community Edition. And I mean, as I said, even reporting, I mean, there's no need to use the pro version. You can it's just a bit more hassle, or it's just a bit more back and forth between the code and your template to do the same with the Community Edition. About the using the CE version, the Community Edition at companies, absolutely. It uses a BSD license, which is very permissive. So you can use it. You can do closed source solutions on top of it. So absolutely, and I can assure you that it's used by pretty much all major bigger companies here. So there's no issue with that at all.
And in fact, I mean, it is actually xlwings is actually distributed in the base Anaconda build. Is that correct?
Yes, absolutely. So most of the companies that we deal with here at xlwings, they do by far the biggest chunk of them, they use actually an Anaconda distribution. And as xlwings, as you say correctly, is included in the base Anaconda distribution, that makes it very easy for you to get access to the xlwings package. So most of the time, you have some internal IT distribution where you can just order the Anaconda distribution, and that usually works very, very well in most of the companies that I that I have looked into. And surprisingly, like when I left, UBS back in 2014, that seemed like very, very far away. But these days, like the biggest banks and like more shutdown banks, they actually have like a one-click installation. So there has been a lot of things going on in that regard, which is awesome. Okay. At this point, I guess I will continue with my next demo, which is showing you basically the capabilities of using xlwings as a replacement to write macros. So the classic tool, you click a button here and something happens. And so this, as I mentioned a couple of times now, this was kind of the starting point of the library. So it's a classic use case where you have a computationally intensive task. So what I'm doing here is basically I use a Monte Carlo simulation with over 1 million pseudo-random numbers. And that's just a classic example where you definitely don't want to use Excel for handling the pseudo-random numbers. And it's funny, like how many times I've seen like clients use a spreadsheet where they kind of, try to come up with some sort of random function formula that gives them some random normally distributed random numbers. And they do that really 10,000s of times, but only 10,000s of times. And their spreadsheet has already grown like to 60 megabytes or so, and is like hardly usable anymore, because like as soon as something recalculates, then good luck with your random number functions in here. So this is really the classic example of how you can use Excel as a pure front end. By looking at the numbers here, they are all just hard-coded inputs, values, as well as here as the outputs. They are just values that are pasted back from Excel as a data frame, and everything else happens in Python. The good thing about this approach is also, I see a lot of users use this as basically getting something off the ground. So they may not be like HTML web developers. They know how this works. They can throw something together real quick. And then maybe if this is a tool that many people will be using, then somebody else who is good who's basically a web developer, they can take care and move this whole logic of the tool into a web-based application. And that is really simple to do, because doing a real quick look at the source code again, they can basically take out the analytical stuff and just have to replace basically kind of the inputs here. So they would just go and replace that with the basically like getting the values like from a JSON object if you communicate like with a web front end, and then they can like leave the rest untouched. So like probably you have a function where you then do the simulation part, so they can just take that over one-to-one, and they don't have to re-implement any of the computational part. Or you can just take that and use it on a Jupyter notebook too. And that's like the thing that I don't like about basically the standard Excel setup. So like if you use VBA, or like even if you use some of the modern Excel stuff like Power BI too, but mostly like Power Query or Power Pivot in Excel, then it's like you're really tied to Excel and you can't like take it out and then maybe continue on a Jupyter notebook. Whereas maybe you feel most comfortable in Excel, which is fine, but then doing it in Python just leaves you so much more room to take the next step when basically you add some machine learning to it and you need some GPU that you don't have locally, so you can just run it in the cloud. So that's really, really easy to do from here. I said, the source is on GitHub. You can look at it in more detail, but again, it's really just I showed the inputs. It does some calculation steps here, and then finally it just throws out the output again here to Excel, and that's pretty much it. That's how you can have all the heavy stuff going on in Python and really reduce Excel to being a front end, which is very intuitive to create and very easy for almost every business user to take care of themselves. And that's about it. So as a fun fact, this was really just a Monte Carlo simulation based on like a year data of the past year of daily returns. And as you can see, funny enough, it does a relatively good job in the current environment, at least for Microsoft. Like if you would change it to some other stock, then obviously the results will look probably a bit worse. But sometimes I guess even like a simple simulation like this is almost sticking pretty close to where you would where you would expect it according to like this 95% interval here, or the 90% interval here. But I'm sure you all have some much better methods to predict stock market's outcome much better than this part here.
Felix,
Yes.
Zhang is asking, how is the run button itself implemented? Is it in VBA or in Excel?
Yeah, right. Yeah, so there's different ways you can do about it. You can either use you can hook it up with a function which is called main, and then just use the xlwings run main from the add-in here. But you can also basically, you don't require the add-in, and you can use buttons as you've always used them. And so to call that, all you would need is basically a VBA three-liner, well, a one-liner, which just calls the run Python function here, and then you import, you just execute Python code, and that's it. So yeah, you hook it up either in VBA or you call it main, and then you don't even have to do the magic here. So you can just hook it up to the run main button there. All right. This brings us, as usual, to the poll results. And yeah, so I guess many people, they know about basically the computational attractiveness of Python and the scientific library, I guess, which definitely pandas probably like in the front line definitely made Python so brutally popular in finance. And so to come up here with basically to introduce the last part of the demo, I'm interested to hear from you in terms of, what are the issues you usually face with Excel? I mean, everybody complains about Excel usually. Obviously, some people love it, but often people complain about it. And I would be interested, what are exactly the issues that make you complain about Excel, or maybe why? Where are the weaknesses in your specific case where you would say that for you it's really an issue? I believe you can select different answers here. All right, so this will
Felix,
lead me now.
Sorry, just
yes?
one more question has come in. I think that an interesting one here, just kind of coming back to the other one, the other previous sample before we move forward, is that the common scenario of Jonathan is asking, common scenario of very slow Excel performance is, loading large data set, cleanse, pivot, report, not extensive computation, just lots of data transformations and so on and so forth. I mean, does moving that from sort of formula-based stuff or pivot table-based stuff in Excel to Python, moving that to Python, speed it up? I think the answer is obviously yes.
Yeah,
would you say?
Absolutely. So yeah, absolutely. I mean, there's a couple of things that slow down Excel. One is if you just have a lot of data in Excel. So you shouldn't misuse Excel as a database. A lot of people actually do that, and Microsoft has done some sort of good job in introducing Power Query for that. So basically just, make a query to an external application, like a database. There you can store petabytes of data if you want to, and then you can just query it into Excel. So that's one part of it. And Python definitely is my recommended way of doing that. The other way is if you have a lot of calculations in a lot of formulas in Excel, that also makes it very heavy. So it's really a combination of these. And if instead of having nested ifs and thens and sums and pivot tables and whatnot, if you just have a single call to Python that does the number crunching, where you can use pandas, which under the hood uses C code and Fortran code from back in the days, which is really fast, then you will have a lot less issues. So definitely encourage you to try this out. Yeah.
I will go further than that and obviously say with Python as well, you can then enter into, basically parallelization, vectorization, and such kind of stuff. Literally with to vectorize and parallelize, basically it's a one-line, it's almost literally one import statement and a one-line function modifier if you use Swifter. or something like that. So, it is a completely different computational paradigm and so much more efficient than anything you would ever be used to natively in Excel. So, let's move on. There's tons more questions coming in. I'll leave them to the end, though, so we can crack on.
Okay, no worries. All right, so this is basically the last part of the demo, and as I was initially saying, this part is for this time not about how to connect to Eikon and make something out of it, but it's about basically, it's kind of wrapping up what I initially said about what our mission basically is. And the mission is to make your work with Excel easier, hassle-free, and basically give you an alternative to moving away from Excel, is to basically give you the right tools to work with those Excel workbooks. And as I also said initially, we try to give you like a developer's tool, because Excel is nothing else than a programming language. So why should you treat it differently? So we say it's really not Excel as such to blame it for all these issues. It's the way how you treat an Excel workbook. And so one of the ways to, one of the cornerstones of programming and making programming safer than just a random spreadsheet is by using unit tests. And a lot of people make book or whatever program you're dealing with just, hundreds of times safer to use than without it. And so how does it work? So I have here on the left-hand side, I have like a dummy calculation, classic thing. You start in January with your budget 30 balance, and then you've got inflows and outflows, and then at each beginning of the month, you take over basically the ending balance and so on. And this is basically how you plan your budget for the full year. And obviously, this is a really stupid example, just so it's easy to follow. And so what I've written now is a simple unit test. And so this again is like it's actually a concept that we didn't really invent ourselves. It was brought to us by some of the clients we have, and they were just saying, look, we are doing this. Please tell us that everybody's doing that. And so we started to promote that because it's really, really easy and really makes a lot of sense. So all you need to do to write a unit test is basically you write a Python function. And this Python function then basically sets a value, sets the starting point. So this here, it's just like named ranges here. Then we set the starting point to the deterministic value. We set all the inflows here, which is basically the full row in here. That's this one here. That's the inflows, and the same for the outflows. You just set them all to the same value. So we know that over 12 months with a net inflow of 5 per month, we're going to end up at 160 at the end of the year. So that's our final number. And that is all we need to do. And so basically the test really consists of, comparing the result that Excel comes up with the result that we expect. And so to run that, I need to find the correct prompt here, which is this one. So to run that, I would just call PyTest. PyTest is a test framework in Python. And PyTest now takes care of running that test against my workbook. And so it pastes in the numbers. It does so in the background, so I'm working actually on a copy. But the important part is you can see the test passed, and it's green. And so this means probably I don't have anything messed up, like really fundamentally. But so as I said before, Excel is really kind of it's a programming language which is in constant debug mode. So you can see the value here, it's 30, but usually you don't see the formula here, the C5. So just by looking at the sheet, it's very hard to find out if maybe there was an error. So if I do this, it looks exactly like before, and the values are the same. And maybe some people do that just to, find out how the projections would change if, that big order would come in. And if you do that on a Friday evening, and while you do that, you get a phone call, and then, you go home and you come back on Monday, you will never, ever remember that probably, that you changed something here in the spreadsheet. And so these unit tests it's exactly to prevent such errors. So if you do run the test now, you will see that it's blowing up all in your face, and everything is red. And it tells you that basically, it gets 80, whereas it would expect 160 given the inputs that we provided. And so that's a very neat way for you to know, okay, hang on, probably something is not quite right. And obviously this sample or this test that I'm doing here is just one of, many, many different things that you can test. I mean, if you have a really mission critical workbook, you could write a unit test which would make sure, for example, that this indeed is really the difference between these two numbers. I mean, it's basically wherever you want to go with that. But it's definitely, it's a very, very solid way to get your spreadsheet, to get a bit more confidence about your spreadsheet. It's also like, often when people take over like a legacy spreadsheet and then have to do some changes, they feel very uncomfortable. And adding a few a few tests that make sure that at least like the basic relations still work the same after a refactor gives you a ton of confidence. And it's also very easy to do. If you use VBA, then you can use it on VBA functions. So in that respect, it's really, it's just the perfect unit testing framework to test your VBA-based functions. And to wrap this up, I was initially mentioning that xltrail will help you to version control these Excel tools. And so I'll just quickly would like to show you how this looks in practice. And so you can track your workbooks with a tool, maybe like GitLab or GitHub. But then when you go on the Excel workbook, the issue that you always have is this is all you can see. So unlike with source code where you can see the content and also what changed, well, GitLab or GitHub, they will just version the Excel workbook for you, but they will not give you anything else. So you can see that it was me who made the change 2 weeks ago and what I changed, but we just have to trust that. And so what xltrail delivers you on top of that is basically, it allows you to synchronize with Git repositories, or as a lot of business users aren't really happy with using Git, you can also just drag and drop new versions on xltrail directly. And then you basically have all these Excel workbooks in here, but with the difference that you can actually look into the content of these sheets. And so when you go into the history and you click on see changes, then you will actually see what exactly I changed. You can look at them in the detailed view here, and you can exactly see such a change that I've just made. And it's basically it's allowing you, it's giving you access to all the programming best practices, in the sense that you can have a colleague or a team head peer review your changes in Excel, and maybe ask questions about why somebody or you replaced this this hard-coded number here with a formula. I mean, this is obviously to fix the error, but I believe usually it would be the other way around, where you basically have a case where that is the usual case, right? What I've just shown you, where you replace a formula with a hard-coded value, and that just raises questions. And it's a very good way to keep an eye on what's going on with your workbooks, in the same way that you deal with source code. And so like if you start using this methodology, like if you start testing, writing automated tests for your workbooks, and if you start tracking your workbooks in a system like xltrail, where you have the ability to do peer reviews, then you will see that the initial news from the London Whale or from Marks and Spencer, these cases, these issues, they will most likely disappear, because, well, you're using basically the same practices that help software developers to minimize the possibility to introduce such issues. And just before wrapping this up here, this was a too simplistic example, so maybe real quick, this here is another example where we have a bit more content here. So we have a lot of sheets in the workbook, and we have a lot of code objects, a lot of VBA code. So at least like for things like if you do have VBA code, then it's easy to look at what's going on. So this case here, for example, was a case where I was removing a column and then wasn't aware of some hidden columns referencing still the formula. And so I was introducing reference errors in a hidden part. And so it's kind of a classic example where you want to be able to see really what's going on, where your changes that you were intending to do, were they really the changes you wanted to do. And then basically you can see the same here on the VBA part, so you can really see what's going on. Again, like in the detailed view, you can see like, okay, here we do have a column that was deleted, and it just gives you a really neat way to collaboratively kind of work on the same workbooks. I guess a topic which is a bit more popular nowadays. And I believe that's pretty much it. So I hope that I could give you a few hints on how you can automate your workflow using xlwings to basically get rid of definitely the most likely way of breaking things, which is by manual copy pasting, and a few hints now in this last demo of how you can like introduce some neat practices to basically make your way to work with Excel more secure, and hopefully will give you a real option instead of just moving away from Excel. Maybe just treat it in the proper way to make your life not only easier, but to really bring your work on a more stable basis.
Felix, thank you so much for that. That's super kind of informative. I mean, actually, I've been a bit overwhelmed. We've had over 650 developers on this call, and I have tons of questions. I know we're running over, so I think we're okay to continue for a while. So I think there are many questions. I mean, you're okay to continue to answer questions for a while?
Yeah, sure. I will also, sure, definitely. I'm also like giving the results of the poll in the meantime, and okay, definitely great. Interesting to look at. So that's very, very informative. So definitely performance and size being like the biggest issue here, and also scaling and version control. So yeah, version control is exactly why we built xltrail, and scaling, I guess, is really a topic where you can, performance and scaling is a topic where you can probably get a foot in with, or probably level it up by switching to Python.
Okay, and in terms of sort of okay, so in terms of sort of questions, let's have a look, because we had like tons of questions. So, okay. So again, following up on something, so xlwings may not be able to access all the parts of Excel that VBA can, was a kind of follow-up question to, I think, can we work with various different types of objects with xlwings? You went into it a bit, and somebody.
Yeah. So Yeah, so the summary there is you can definitely do everything. It just maybe more work or not. So if you go to docs.xlwings.org, then you will find like missing features, and it explains everything. So basically, you know, there is always a workaround that you can use, and if you are on Windows, it's always pretty simple. So it's just like falling back to .api, and then basically you have the whole the whole API available. So definitely a yes, but it may be a bit more work.
Okay. So I mean, I think we're going to have to kind of keep these questions. There's some quite complicated questions here, so I don't know. So for UDFs, what are the steps to deploy this so other team members who aren't familiar with Python and don't have Python on their machines can use it?
Okay. So they will need Python on their machines. That's a given. So currently we do not have any way to remotely calculate these UDFs. So what they will need is absolutely a Python installation. But you can usually keep this simple by having them install the Anaconda installation, and well, just giving them basically the Excel file and the Python code. Or if you use xlwings Pro, you can just give them the Excel file and you know, have the code embedded. That definitely helps in deployment. We also have another Pro feature for deployment, which allows you to build an installer which packages up everything, all your Python dependencies. And depending on what that is, it can be, you know, as small as 50 megabyte as an installer, but it includes maybe NumPy or Pandas even. And what then the users can do is basically it's a one-click zero configuration installer. So it unpacks it into a specific directory, and your Excel workbook then knows where to look for this directory. And so it's basically you just have to give the users the installer, they double click it, they say, okay, that's the only thing they have to do. And then they open the spreadsheet and they are ready to go. So once a spreadsheet has been set up with the user-defined functions, you know, you can cut it down to just having a Python runtime on the recipient's machine. But there's no way around Python for now.
Great. Okay. So let's try. I mean, we need to push forward quickly, I think. But let's how do you convert a Python function to a UDF in Excel? Just quick answers, because we've got so many questions here.
So what was that?
How do you convert a Python function to a UDF in Excel?
Okay, so basically you just have to put the function decorator on top of it. Yes, and then click on the import functions here. So in our example, that was here. So basically have a decorator, the xlwings.func decorator on top of it, and then this will be available after the import Excel function button in Excel. But you only have to do that once. So once you have imported it, you can send it around to somebody and they don't have to re-import them again.
Perfect. We got a couple of questions here. How fast is dynamic update of Excel? Is it possible to create a pop-up window with an expected time of update or other indicator in case it takes long? So that's one class of questions. And the other second follow-on question was that, do you have like a progress indicator, you know, that you can do from Python to Excel? I believe you can do that as an object. And then also there was a number of questions to do with real-time updates. So this is about dynamic updating of Excel. So that may be processing stuff in Python and then sending that to Excel. How performant is that? And then this kind of progress indicator. And then after that, the real-time stuff may be to do with RTD server. I don't know.
Yeah.
Quick one. Sorry. These are big subjects, I know.
No worries. So the progress indicator, there's nothing built in currently. But you can use techniques on your side to get a pop-up with using various technologies. So you should be able to use probably one way of definitely that works is like showing it in like in the, what's it called, the taskbar like below here, right? Then another way is definitely using a Python GUI tool, which can, you can create a pop-up and have a progress indicator. I'm not sure if you can actually use an Excel pop-up itself. I believe that's probably going to be blocked during the call. But there's definitely ways how to do it, but there's nothing like out of the box that we currently supply. And about the real-time update. So, I mean, one question was about, I guess, getting streaming data into Excel in terms of real-time connections to Eikon. So currently, we don't offer an RTD class or something where you can build an RTD server and consume the real-time data in Excel, but it's on our list of things that we are going to add on the Pro version, hopefully real soon, and that will enable you to consume the streaming API from Eikon. On the side, if you are a modern hedge fund and use Macs, then there's some good news there, because none of these functionalities are kind of natively supported on Excel for Mac, so there's no RTD on Mac. But using xlwings, you will have a possibility to basically still store data relatively in an easy way to Excel. It's not going to work with formulas, RTD based. As I said, it's just not, as a platform, Excel on Mac just doesn't support that. But it's really simple to just write a bit of Python code and then stream it basically from the Python side into Excel. So definitely things that are doable. Maybe give us a few weeks, and then we'll probably, hopefully, support them professionally.
Perfect, lovely. And yeah, so I think actually we're being asked to stop now. I mean, I have so many more questions. So, I mean, unfortunately, we're sort of coming to the end now. I don't think we can really handle any more, because I think the person who's helping us with this presentation actually has another webinar to go to in 5 minutes. So what we will come back to you with. We have a list of all of your questions here, all of your numerous questions here. So thanks so much for asking all those. We will get back to you with more detailed answers than the ones that I've tried to give myself to your questions, and Felix has done there. So we will have a thing, and we'll come back with proper answers for all of those things. Just before we sort of wind up, I'm just going to post some links. Obviously, we've got some more events coming up. We've got on Thursday, we have basically a link for the Python for Quant Finance event. I've just posted a link for that, I believe. And then we've got it on the 21st. We've got a whole session on ESG data. So I think I'm going to post a link about that as well. Hello. Yeah, I'm just going to post a link about that as well. And then, sorry, this thing's. So I'll post a link about that in a second. And then also we have free trials for those of you who don't have Eikon and like what you've seen today. There's so many more things that we can do here. We've only just literally gone through a few examples. I can then you'll be sent in the email follow-up here. You'll be sent a link so that you can actually just click on that, and then basically you can just register for a free 1-month trial of Eikon with the access to the Eikon data API that Felix was demoing today. And if you're interested in more information about that, please just go to developers.refinitiv.com and type in Eikon data API, and then basically you'll have lots of resources there, from tutorials, tons of Jupyter notebooks. We've got articles on there, and we also have a Q&A forum there. Then okay, we're having some problem with the links now, so I'm just gonna okay, great. And then I'm just going to send the second link as well. Just hang on a second, and then basically I think we're going to have to almost wrap up there. Hang on a second. I'm just going to dump this link in for you here. Sorry about that. Okay. Okay, and that's an ESG event on the 21st. So you can find all of those events just on the events section at developers.refinitiv.com. I think we're going to have a time for a proper summary here, but we've seen so much today. We've seen some problems related with Excel. We've seen how you can use it interactively with Eikon. We can move stuff, take stuff away from local computation in the Excel kind of kernel itself, push that out to Python, have much more efficient code experience. And really, there were many questions about performance today, and there are so many actual performance reasons why you would want to go with the Python over Excel. And then we have all of the stuff to do with the security. Before the security, we saw the reporting kind of thing, error-free reporting, and that's all available for you there. So kind of easy to implement for people there. Then we saw the auditing, spreadsheet auditing, which is a huge thing. And I think every company, IBM statistic, is quite standard. 89% of spreadsheets globally contain errors. So that is one real massive way that you could implement to reduce the instances of that. And let's face it, we all work in large companies with large amounts of money at stake, so we should really try to investigate anything we can do to reduce those risks. After that, we've seen some polls. So there's plenty of you had answered the polls. So there were clearly a lot of you are interested in this area. Some of you know about it. About a third of you seem to know about it. 2/3 still didn't. So there's a lot of stuff to do. If you want any more information about xlwings, please, xlwings and Felix are a partner on our site. So if you just go to the partner section, the partner gallery at the bottom of the site on the homepage, you can just find xlwings as a partner in there, and Felix's details are all in there. You're going to also get them, I think, in the follow-up email. So if you want to have any contact with Felix, he's available through any of those routes there. All of his code samples are going to come to you, as well as his slides in the follow-up email. The free trial is also in the email. I've given you the links here. I think, Felix, that's it. Anything to add last minute?
No, I think it's been a good summary. Yeah, definitely.
Lovely. Okay. Thank you. Well, thank you so much all for attending. We had a really massive turnout here. I was struggling a bit with the questions, but we will get back to you. And please register for the upcoming events, and we look forward to seeing you very shortly. Thank you so much, and have a fantastic rest of your day.
Thanks. Bye-bye.
Bye-bye.